All right. Thank you everyone once again for joining me today. My name is Arvind Krishnan and this webinar is about post-processing your analysis with SOLIDWORKS Simulation. I have worked at GoEngineer and involved with simulation technical support for the better part of the last 8 years. So really excited to bring this topic to you because there's always that one functionality that we're looking for which we don't know how to get to. So my goal today is very simple. My goal is to, and my hope is that everyone who is attending this webinar today can get out at least one functionality that they didn't know existed before. So let's go ahead and get started. First off, any simulation that you run, let that be a CFD study, an FEA study, there's 3 components to any simulation you run. The first one is going to be setup, that is, or pre-processing, where you're describing the boundary conditions, a fixture here, a load over there, what material is used, meshing the model, all of that constitutes the setup. Then you have the run, or the actual solving, where you are specifying, once you've set up the problem, it's going to actually run it and then find all the important outputs for you, which in the case of a static analysis is going to be stress or displacement, deformations, strain, all of that. And finally, you have the post-processing, which is what do you actually do with these results? Now that you have all of them available, how do you make sense of it? How do you actually extract some of the critical design parameters that are going to enable you to make the decisions that you want? So we did a quick test on some of the simulation tech support cases that came in to GoEngineer. So a percentage of cases in the recent history, installing SOLIDWORKS simulation. That seems something that's pretty important, right? About 10% of the cases are just installation of SOLIDWORKS simulation. Setup, which is the pre-processing, which is what most people call in about 40 to 45% call in and ask, hey, how do I set this up? This is what I have a question on. I don't know how to do this, or this functionality is not working properly. How do I get it to work? That's the setup of it. And that's a majority of the cases that come in. Next up is we have the actual solve or the run. And that's another 25%. And finally, the post-processing is 25% of the cases that come in. So 25% of the cases that come in to our tech support queue is asking about how do we extract the results that we want after we run an analysis. And that's going to be the focus of our results today, of our webinar today. We're going to start off with the basics. Default options, probe, animation, showing max annotations, mesh, section clipping. So let's go ahead and get started. If there's one thing I want you to take out of this webinar, just one thing, it's going to be how do you change some of these default options. Let's go to SOLIDWORKS, and I'm going to go ahead and pull up my model. And very simple, couple of clicks. So go to simulation at the very top and go to options. And under the default options tab, there are a bunch of different settings here. If for a lot of folks out there who don't work in SI units, you can quickly and easily switch to English units. You probably don't look at stress in PSI. Let's say you prefer KSI. You can go ahead and switch that. Length, if you're working with relatively bigger parts, maybe inches is not ideal, you can switch that. Another thing is, I'm going to show you 2 more options here. The first one is your default plots. Let's say you look at principal stress or stress intensity all the time. You can go ahead and add that as a new plot that will always be available to you anytime you run a linear static analysis. You can go down, select what type of result you want, and then go ahead and select the stress intensity as an option. I already have this, and that's why it's warning me about that. Okay. I can also go ahead and edit the specific number format, and this is something that is going to be very useful to you. So this is by default in a scientific mode, which means if you have, let's say, 0.5 inches, it's going to state it as 5e-1. I don't know about you, but for numbers that small and that close to 0, I don't want a decimal place. I don't want a scientific notation there. So the general works better in that case. There's a couple of other options here that you can explore, but I do want to show you where some of these default options are, which I think would be very useful. Next up, we're going to talk about the probe functionality. In SOLIDWORKS Simulation, you can look at a plot and it looks great with all the colors and everything, but if you want precise information on what the exact stresses are at a particular point, how do you get that? You get that using the probe functionality. So here I've ran a study already, and for this edge, I want to know what the stresses are in that specific edge and how does it change from one point to the other. So I'm going to go ahead, right click and select probe. I can do probe at one specific node location, or I can switch to on selected entities, and I'm just going to pick that edge and then I'm going to update these. So all of these tell me the different nodes in that edge and what the subsequent stress value is. Something even better is I can go ahead and use this plot option in the bottom, and using that plot option I can go ahead and look at the distribution of stresses across that point and how it changes as I go from one side of the edge to the other side. By the way, if you guys have questions about some of the functionalities I'm showing, please feel free to include it in the chat box and or in the questions page, and we'll answer them at the end. Okay, so that was probe. Next up, we have animation. Animations are important. One thing I would like to point out about animations is keep in mind, right now by default I have a magnification scale of 7.4. This is a number that is arbitrarily selected by the SOLIDWORKS Simulation tool. If you want to change it, you can double click on that box and change. So let's say I want a value of 5 such that I'm comparing different designs and want a constant magnification scale. I can go ahead and change it to 5. So we were talking about animations. To do that, right click on stress and select animate. By default, it's going to pick 5 steps and show you an animation between them. You can reduce the speed. You can go ahead and stop it and let's say include 10 steps so that you have a more smoother animation of how it moves. You can have it go different options in terms of how it oscillates between the frames. So that's animation. All right, let's keep going. Next up, we have show max annotation. This is a relatively simple one. What it means is if I want to know what the exact stress is at that point, or the maximum stress, because that's more often than not a point of concern and something that's seen very often, I can just double click on this color chart legend and click on show max annotation, and it takes me to the point where the stress is the maximum and it shows me exactly which node it is. Typically, if you double click on this color chart or on the name on the top, it brings you to this page where you can change any information about your specific plot. So again, definition is what plot I'm looking at. There's some deformation scale values. Chart options is do I want this floating? Do I want it a scientific value? What are going to be my upper and lower limits? I can go ahead and change all of that inside for each plot. There's also settings where I can go ahead and look at a mesh overlay and see how that looks and what's my mesh density with each of these. Okay, let's go ahead and move on. The next is mesh sectioning. For those who've done SOLIDWORKS and used simulation before, you typically want 3 elements of mesh across the thickness of your model. So how do you go ahead and actually check what the mesh density is on the inside? inside meshing, you can go ahead and create what's called a mesh plot. And I'm just going to select mesh, which is the default, and hit the green check mark. And I can see my mesh on the outsides. But I can also right click on this specific mesh plot and select mesh sectioning. And what that does is it actually shows me the mesh on the insides. And I can go ahead and toggle this and move it along and see the mesh in the different areas. Pretty cool functionality if you want to make sure that you have 3 elements across. So for example, here I kind of see 3, maybe not. If I want to increase the density of this mesh, then I know that I can go ahead and enter a smaller value. So that is mesh section. Next up is section clipping and ISO clipping. Okay, so I want to quickly show you how this works. Let's go ahead and hide this. Let's go back to one of the results. So section clipping is how do I look at the cross section of my results and see what's happening inside the model. A lot of the times the max stress regions are outside, but we also want to know what's the distribution through the part. To do that, right click and select section clipping, and then you can select a specific plane that you want. So in this case, the front plane shows me the distribution of stresses on the inside of that front plane, right? Very useful functionality. Now, for those who are going to be using this the first time, let's say you hit the green check mark and you don't know, how do I get rid of this now? To get rid of it, you got to go back to your section clipping, and then there's this little toggle box right here on the bottom that says clipping on off. You got to click that again to actually get rid of it. So that is section clipping. We also have ISO clipping that shows you some of the regions with the highest stress. Once again, I'm going to right click ISO clipping, and it's right now defaulting to a value of 106, just somewhere in between 0 and the max number. I can take the slider to the left, to the right, and basically that's going to determine, it's going to show me all the colors or all the regions where the stress is above the certain number that I have. So if you have a certain limit that you want to stay below, you can see all the regions that are above and maybe thicken this fillet, increase the value, or increase the thickness of a certain region. So that's the ISO clipping. And lastly, I want to talk about the reports before we go into some more advanced options. So, report. Oftentimes you want to document some of the steps that you're taking. You want to document the setup, some of the post-processing analysis you've done, the mesh, the solver type, and all of that is possible using one simple click, the report button on the very top. Okay, you can click on report. You can go ahead and put in some company details, maybe a URL, and it's going to use all of this. And when you hit the publish button, it's going to go through, take a few screenshots of your model, of the setup, of the analysis, or of the post results, specific plots that you've created, and go ahead and create a neat Word document that can then be used and saved and archived or distributed to a vendor. So there's a lot of different options available inside the report tool itself. All right, so hopefully I've shown you some functionality that you haven't seen before. But we have a pretty wide audience today, and there might be a few people who've already seen all of that. So I have a few more options, something that's a little more advanced that hopefully some of the others in the audience haven't seen yet. All right, so we're going to start off with Design Insight. Okay, what is Design Insight? Design Insight is showing you the regions in your model that is contributing the most or taking the most amount of load. Design Insight is available here. So if I'm looking to create a lighter crank design, then I can use this slider, which I can take it back and then forth, and let's say I go to about 99%, I still see some regions that are taking very minimal amount of stresses, right? So if I want to reduce my weight, these are some of the regions that I want to target to reduce the weight in. Okay, this is not a full-blown topology study. It's just looking at regions of high stress that's contributing the most to the stiffness and showing you the results of that. So this is design insight. Okay. All right. I'm going to go ahead and switch to a different model as well. Next up, we're going to look at symmetry of your results. So a lot of times people use symmetry and it's awesome, right? You get to just run the analysis on half the model. In this case, I've done 2D simplification and I've used symmetry. So my run times are going to be way faster, right? And in this case, I'm doing a nonlinear analysis, and hence I really want to keep that runtime low because I need to run it for multiple steps. Here is a stress analysis result at one specific time step. And before we show you the symmetric results, I want to tell you that, so this specific study has ran for 49 time steps. What that means is I actually have 49 sets of results, and I can analyze the result at any one of those steps. So I'm going to double click on this box, and let's just go and switch to step number 30, right? And then we can hit the green check mark, and that is step number 30. So you see that the results are slightly different because it's at a different position. Okay. Another thing that you can do, double click on this box again, and we can go ahead and go to the advanced option, and we can actually look at the display symmetric results. Okay, let's go ahead and hit the green check mark. And now you can see that even though I ran my analysis on just half the model, I don't have to look at the results of just half the model. Your boss doesn't have to know that you ran the study in only half the time, right? You still want to look at the results for the entire model. So because you use the symmetry functionality, your results can go through the same symmetry plane and show you the entire results on the entire part. This works for a quarter symmetry or an eighth of a symmetry as well. Another functionality I want to show is you can go ahead and look at the results, or look at the maximum results or the minimum results across all your steps as compared to looking at the stress result at one specific step. The benefit of this is, let's say different regions in your model experienced the max stress at different time steps. If you're analyzing one specific time step, you don't see the maximum stress results in other locations, which happens at other time steps. So if you switch to the max option, it's just showing you the maximum results across all of them. And that might happen at different time steps. Okay, so let me go ahead and switch back. We'll go ahead and switch back to one specific step. All right, next up, I want to take you to the probe functionality again and show you something new. Since I have done a nonlinear analysis in this case, I'm going to go back and use the probe functionality. Right, I'm going to select a specific point, but this time, instead of looking at a graph of multiple points as I showed you before, we can graph the response or the stress of this point with respect to time. So here is a graph of how the stress distribution is in that one point across the length of time, right? So this is how the stress results are as a function of time for just that one point. Very neat feature and helps you analyze. And of course, you can export all of this to Excel as well using the save option here on the bottom. Moving along, once again, you might have done a 2D analysis, but you can still look at the results in 3D. How do we do that? We're going to go back to that same menu, and this time I'm going to say show as 3D plot. Pretty cool, right? So what happens is, even though once I specify my thickness, I actually see the entire part, and I can see the same stress distribution throughout the part, which I had in my 2D layer. Okay, so that's showing the results as a 3D plot. Okay, vector plot options. So I did part of my research on this, and this is actually pretty interesting. So let me go ahead and take you back to this. And So what happens here is you have the ability to look at, I'm going to go ahead and create a new plot real quick. Let's say we define a stress plot, and I'm going to change this to just principal stress 1, and I have the option to say show as vector plot. Okay, principal stress 1 actually has direction as compared to 1 Mises, which does not have direction. So what this does is it shows me these arrows, and if you think it's too small, I agree, you're going to go ahead and make some changes to that. So you can go and do a vector plot option, and I'm going to go ahead and increase that the density of the arrows, and I'm going to increase the size of the arrows. Okay. All right. So now what these arrows are actually showing me is it's showing me the direction of stress in the different regions. Okay. So once again, you see regions here that are relatively blue where the stresses are less, and that means the principal stress 1 over there is relatively low. Now, why is this useful? It helps you determine the direction of stress from one point to the other. So if you're once again creating a topology optimized shape, these arrows and the direction of these arrows for principal stress 1 and 3 are going to show you where is the best place to place material to get the most optimum or the best stiffness to weight ratio. Okay. All right. That was everything that I had to show you, but I'm sure there's still 1 or 2 people out there who've still not seen something new, right? So I want to show one more functionality, which I have used probably once or twice in my in tech support, right? And this is, what if there's a plot that you want to create, let's say maximum shear stress, that is not available in the default options inside SOLIDWORKS. So again, maximum shear stress, how do I create this if it's not available as a default option in SOLIDWORKS Simulation? And to do that, I'm going to use a rarely used functionality called result equations. If you haven't heard this before, trust me, you won't be the only one. It was a new functionality introduced in 2016. Right click on results, select result equations, and what this does is it lets you type in an equation of the quantities that you want. So for example, max shear stress is something like the square root of stress in the x minus stress in the y squared divided by 2 plus shear stress in some direction. If you know all of that and that's what you want and that's your failure criteria, you can actually come in here and type that out and create an equation for that you can then use. Okay, so again, relatively rarely used functionality, but it's pretty useful if you actually need it. Okay, so that's result equations. All right, I hope everyone has learned something new. That's the majority of what I had for you today. Thank you once again for joining us.